Hello everyone, myself Kamna Singh, Assistant Professor in Computer Science and Engineering Department in Akgec Garg Engineering College. Today we are going to discuss the topic General Register Organization, and this General Register Organization is nothing but it is taken from the subject Computer Organization and Architecture. So first of all, we have to understand what is the register. Everyone knows register is what? Register is the temporary buffer where your data will be stored and for the meanwhile, and register is the fastest memory and the shortest storage. So now we can consider what is the general register organization in the next. Now, the first of all, you have to understand what is CPU and what are their components. The main components of the CPU or a processor. Processor is the central processing unit and its main process is the register set, arithmetic logic unit and the control unit. So, register set here, we are writing here as a register set. Generally, we are considering the term register. Registers are what? Registers are the temporary storage. For very short time, they are storing the content, and after that particular contents will be vanish or superimposing with the other one. Now, register set holds the intermediate data using the whatever the manipulation or instruction execution is there. And the next is the ALU. As the name suggests, arithmetic logical unit, it performs the micro operations for executing the arithmetic operations or a logical operations. Arithmetic operations are like particular addition, subtraction or so on, and logical operations means like the and or not operations are there. And the next term is the micro operations. Micro operations means whatever data is present in the register and you are performing some operations on that particular data which is present in the register is called the micro operations. And the control unit, this is also the part of the CPU. The control unit is there. Control unit is actually monitoring whatever messages are communicating between the hardware components inside the computer system. Whatever messages are there means what? It supervises all the data transfers among the registers and among all the hardware components. Generally, control unit value is C equal to 0 or 1. This C equal to 0 and 1 means when the control unit is transmitting the signal as a enable, that is 1. If the C equal to 1, it means what? Whatever operations is going on, that can be proceeded. But if the C equal to 0 is the disable signal will be proceeded for the data transferring operations, then even though the recipient or even though the sender are ready to send, still that particular message is not going to proceed. That is the meaning of the C equal to 0 and 1. Now, the processor organizations. In the processor organizations, there are actually the types of processor organization is of 3 types. First is the single register organization, next is general register and the stack. Today, we are going to proceed this general register organization. The processor organization means all the arrangement of the registers, ALU, MUX, all these components are to be arranged in order into the processor, then it is called as a processor organization. That means how all these data is to be stored here and the manipulating and the result will be proceed, and that particular result is going to be the output unit. So, the processor organization, and the processor organization is of 3 types. First is the single register organization or a accumulator organization. Accumulator is also written as AC, and this accumulator is nothing but this is the register which is also called as a processor register. Means what? Whatever the CPU, inside the CPU there are the 3 fields, that is register set as we discuss here. There is a register, arithmetic and control unit, and in that particular register is actually the processor register. Processor register is holding all the manipulation or the calculation result will be there in the processor, and this is the basic computer in the single register or accumulator organization. Accumulator is only the general purpose register, and the next type of the processor organization is general register organization. In the general register organization, it is used by the modern computer processors, and any of the registers can be used for the source or destination with the message passing or the computer operations. And the next one is the stack organization. Stack is again of two types, that is a memory stack and the register stack organization. All operations are done in the hardware stack. A stack is just like the LIFO, means last in first out, means there is a push and pop operations will be going on. All the data is stored in the register stack, and the which particular data will be stored last will be fetched first. That is the stack organization. And stack organization is again two types, that is a memory organization and the register organization. Now, there are so many questions is asking that what is the difference between the CPU and the processor? Is the CPU is the processor or the processor is the CPU? Both are the synonymous terms or not? But actually, CPU and processor. CPU, as we know, that is a CPU is the central processing unit, and CPU is the main part of the computer, or we can say that is the brain of the computer. So all the processing is done here. All the instructions, manipulation and calculations are done here in the computer system, and generally we are using this Ryzen 5 or a Intel core. And next is the processor. If we are talking about the processor, there is a processor is a any chip that process the data, that is not just the CPU. Means every CPU can be a processor, every CPU is a processor, but not every processor is a CPU. Processor can be a network processor that can be handle the data, or there is a GPU processor or which can handle the audio and video signals, and CPU is used for the general task. There is a DSP as a digital signal processor is also there. So every CPU is the processor, but not every processor is a CPU. So that is the main difference between the CPU and processor. Now, these are the main components as we discussed, and here this is the control, and control unit is directly connected with the register set, and register set is directly connected to arithmetic logical unit. So today we are going to discuss this register set is how these are communicating. Now, the registers are the accumulator or a general purpose register. In the modern CPU, there are many general registers are there. The advantages are there, that is a transfer between the processor and the registers. It's very fast if we are using the general purpose organization. And if the processor is off, then access memory is much slower as compared to when we are using the general register organization. So this is the simple concept of the general register organization. General register organization is nothing but it is the organization or arrangement of all the registers, that how they are communicating each other. So in here, in this particular 8085 processor, there is a 7 R1 to R7, means 7 registers are there, and we are going to take the names R1 to R7. Fine. And there is a mux, 2 multiplexers are there. In the multiplexers, there are the input values and output value. As we know, the mux is what? Mux is the combination circuit that takes input as a multiple inputs and produces a single output. So here you can see here, that is the 8 cross 1 mux is here, because 8 values is considering here in the mux, and the output will be produced as a only 1 bit. And there is a 8 bit is taking here, and the only 1 bit is there. Now next is the ALU or a arithmetic logical unit is there. In the arithmetic logical unit, there is a OPR is the operation code. Fine. In the simple world, if I am taking here, the example is R3 is to R1 plus R2. Suppose I am taking this simple example, that the content of the R1 and content of the R2 is going to be added, and the result will be stored in the R3. Then how this particular process is considering here in the general register organization. In the general register organization, first of thing we have to understand that there are the first general register set in the register, because there is a manipulation is going on, so that there is a clock is also there, because all these in the register, the content value will be stored here, and this particular content can be manipulated by the other particular values are to be going on, then the previous one will be vanishing and the new one will be stored. So every time there is a manipulation and calculation is going on, and the resultant will be stored here. That's why there is a need of the clock, first thing. Then the next is the multiplexer. Multiplexer, why we are taking two multiplexers? Because there is a two values. Operands are there. Operands are what? Operands are what? In which all the operations, whatever operations are performing on which type of variable is known as the operand, and whatever operations you are performing, that is called the opcode. So you can see here, this is the your opcode, and these R1 and R2 are the operands. These are the, you can see here, as in these are the operands. So R3 is to R1 plus R2. All these results will be stored here in the ALU, or arithmetic logical unit. Because the ALU is the arithmetic logical operations, so OPR code or a operation code will be here. Here you can see there is a three arrows are there, and here there is a 5 arrows. Means in this particular marks, 3 input values are there, and here the 3 input values are there as a selection line. Selection lines are 3. It means what? This multiplexer is of actually 8 cross 1 multiplexer. 8 cross 1 means what? The selection line will be log of base 2 8. That is 3. That's why there are 3 selection lines are there. Means this particular selection line means at the time which particular input is going to be selected to produce the output. And ALU is the OPR, operation code, or a 5-bit code, whatever operation you are going to perform. Addition, subtraction, division, multiplication, whatever operations you are going to perform. This particular output is again stored in the register. This particular output is going to the register. So all these values will be going here, that is in the register. And how this particular is selected of the for the output, there is a output value will be considered here with the decoder. Means input values is coming with this multiplexer, and output value will be coming from here. 3 cross 8 decoder. Why I am writing here 3 cross 8? Because there are 7 register, and 7 cross 1 I am not going to make. So 8 register, 8 value, and this is the input. So 3 cross 8 decoder will be there. And 3 cross 8 decoder means the selection line is again the log of base to n. That is a selection of D. 3 selection lines are there. If I am taking again this particular example, R3, R1 plus R2, it means what? Actually, this R3 is going on, R1 content and R2 content will be stored, and R3 will be there. You can see here, means what? R1 content, this R1 content is going on here. This R1 content, this is going on here in the first multiplexer, and R3 content is going on in this multiplexer. And the mux A, this name is mux A, and this is the mux B. Again the same size, 8 cross 1 and 8 cross 1. So the result will be produced by the help of the A bus, and the content of R1 and content of R2 will be here. And the operations are there. This plus operations is by this operational code. This particular result will be stored here in the R3. R1 plus R2, and the R3 result is stored here. This in the R3. So this is thus complete as a general register organization. Here you can see here, that is the memory locations are needed for the storing the pointer counters are there, and also this particular 2 boxes are there, registers are there, and the 3 cross 8 different. So 2 multiplexer selecting the 7 registers of the, also the external data is there by the selection A and selection B, and the bus A and bus B is there. ALU is for the arithmetical and logical operation, and 3 cross 8 decoder is for the selection D. The next thing is the control word. If we are using simply R1 is to R2 plus R3, means what? Here input value is R2, second input is the R3 and the result will be stored R1. Means if this R2 is selected by the select A, in this particular, if I am taking this example, R1 is to R2 plus R3. R1 is to R2 plus R3. Means the result will be stored here in the R1 and R2 plus R3 is the input. So, R2 will be stored here. The content of the R2 is selected by this particular multiplexer and R3 will be selected by this multiplexer. Result will be stored here in the accumulator or a register, and next, and the result R1 will be stored with the help of the whatever manipulation is going on. So, this is the performing that the control unit provide the binary selection variable to select the input as a selector, and the R1 is to R2 plus R3 is there. So, we can see that the mux A, the first multiplexer select A and the second multiplexer selects the select B, and the ALU operations are there, that is OPR, and the decoder is the destination selector, that is the select D. Now, in the operations, how these operations are going to be performed and the control word. First of all, this is the control word. Control word are what? That is the 14-bit value. Control word is the 14-bit value. As you know that the simple word is containing the 16-bit value and word is the smallest unit for the data storage. So, here in the control word means these particular data will be stored in the control unit and it is a 14-bit value. The first input value 3, second input value 3, the third is the result and the whatever operation is going to perform, that is the OPR. So, select A, B, D and 3. Means what? This is the 14-bit control word. Input value when the R1. So, we can write with the 3-bit, that is a 001, R2 then 010. If I am talking about the R7, then the 111. So, and the particular operations, this is the predefined values for the operations. If I am going to transfer the operations, any one, that is a 00. If there is a addition operations, then there is a value is add A plus B means 00010, or the subtraction is 00101. So, if we are going to make the control word, suppose you have to design the control word for R1 is to R2 plus R3. So, the control word is here as, because you know that is a select A, select B, select D and OPR. Fine. OPR, this is the 3-bit value, 3-bit value, 3-bit value and OPR is the 5-bit value. So, for this operation, we are going to make the R2 plus R3. R2 is the first input value which is going to the multiplexer A. So, R2 is generally written as 3-bit as a 2010. R3 is what? That is the 3-bit value. Generally, you can write 3 as a binary as 11, but because it is 3-bit, that's why we have to write here as a 011. Next, the result is there. Result will be stored in the R1 register. So, that's why we can write here as 1, but because it is 3-bit, so we have to write here 001. And operation code. Operation code for plus operation. As you can see here, for the addition, the operation code of 5-bit is predefined. So, you can simply write it here 00010. That will be your answer. So, you can generate any of the control word with the help of this. This is the first input, second input, result and the whatever operation is going on. Thank you.